Hi friends, welcome to my another video. This is the part 4 video in series of lightning protection system designing. In this video, I'm going to cover in detail the rolling spare method for the lightning protection system designing. So let's start this video. Let us consider that this is our project for which I have to design the lightning protection system using rolling spare method. So what is the outer edge of this project? I will highlight here. This is the outer edge of our project, right, which I'm highlighting from pink color. I consider for this project that the class 2 lightning protection system. So as I told you in my previous video, for class 2 type of lightning protection system design, when we will do it through the rolling sphere method, the radius will be 30 meter. Okay, so I will imagine a sphere, okay, of radius 30 meter, as it is a class 2 protection. If it is a class 1, I will choose here a sphere of radius 20 meter, but I selected an imaginary sphere of radius 30 meter, and I am going to roll this sphere over my structure. Okay, as you see, this sphere, imaginary sphere, is touching here and here. So as it is touching to our project at this location, this is the one of the point where we have to provide the lightning arrestor or air terminals. Okay, but you see this brown color area here, the sphere is not touching, so this is the protected zone. Okay, here it is mentioned in brown color, protected zone, and wherever it is touching, the sphere is touching the our project, that is need protection. So I will delete it here. If you will see, our imaginary sphere is touching this location which is in red color, so this required protection. I will roll this sphere again. So here you see, this is our sphere is touching somewhere here. Sorry for my drawing, but our sphere, imaginary sphere, is touching this location and this location. So these points are the required protection, and under this point the rolling sphere is not touching our structure, so this is the protection zone. Again, same sphere, I will roll it. Okay, in that time it is touching here and here, corner points, so these points required protection. Again, I will roll this sphere, it is touching here. Suppose if I will roll it here, this sphere, then all area will be rolled. If I am rolling it, imaginary sphere, I am rolling it here, then it is touching all over the portion. That's why you can see here, this is all area of is required protection. Again, I will roll it. So this is the protected zone and this required protection. Okay, I will roll it again. So this all portion will touch by this imaginary sphere, so this area required protection. As you see, once it's rest to the ground, so it's touching last to here and here, so this area is the protected area. I will show you one video and try to explain you that where we have to provide the air terminal and need lightning protection system, and which one is the protected area. But I hope from this picture you got to know we have to imagine one sphere. As per the class, the radius will be 30 meter, and we have to roll over the project. Wherever the sphere, imaginary sphere points is touching to our structure, that points required air terminals, and whichever area is not touched by the imaginary sphere is considered as a protected zone. Here in this video, you see, this is the imaginary sphere. It is rolling to this structure here to there. Okay, and it is touching these portions, okay, and these portions. Wherever this rolling sphere touching, that area required protection from the lightning protection system. So this imaginary sphere is rolling and it is touching this area. This area is in white, it means this rolling sphere not touching this area. Okay, so that area where the imaginary rolling sphere required touching the structure, it's required lightning protection rods. Okay, hope you are clear. This video I got it from YouTube. Okay, I hope you understood the concept behind the rolling sphere method, that based on the protection class we have to imagine an sphere and we have to roll it all over the project. Wherever the rolling sphere will touch to our structure, that location is a risky zone and we have to provide the lightning protection system, that is the air terminal rod. Whichever area is not touched by this imaginary sphere, that is considered as a protected zone, and we don't need to provide any lightning protection air terminal to that location. Okay, as per this image, it is very clear that at the top, the whole portion is risky for the lightning strike. So we have to provide the air terminal here somewhere and here somewhere here. Suppose it is of 50 meter length, 50 meter length. So what would be the distance between the air terminals? We have to decide. This surface is 50 meter, for example, and this all area is risky for the lightning strike. So we have to provide the air terminals in that surface, but we don't know what would be the distance between the two air terminals. That we have to decide. Apart from that, as per this picture, at every corner we have to provide the lightning arrestor. Okay, that is the air terminals. Okay, we have to provide. But in the flat surface, all area is risky, so we have to calculate now what would be the spacing between the two air terminal as per rolling spare method in order to protect this portion. Okay, so now we will calculate the distance between the air terminals as per rolling spare method. As I told you, for our project is a worker accommodation, and I roll the imaginary spare on our project. So this all area is touched by the spare. Okay, touched by the spare because it's a flat surface. So spare will roll, so it will touch all the area. Now we need to know the air terminal locations. Okay, where will be our air terminal to protect this all roof floor? This can be done by using this formula. D is equal to 2 under root 2 RH minus H square. What does it mean? Here the D stand for distance between the two ruts. So we have to know where will be our ruts. So that we will come to know when we will come to know that what would be the distance between the two air terminals. The R is the rolling spare method radius. Okay, and H is the height of the rod. Suppose I have a material submittal and the rod height is 1.5 meter. So our height will be 1.5 meter. If the material is selected and its height is 1.2 meter, then we will go for H is equal to 0.2 meter. As you see, this is our worker accommodation. Okay, worker accommodation, and the spare of 30 meter radius. Why 30 meter? Because we choose in class 2 protection. So 30 meter radius is rolling over the roof. So it is touching all the top part of the worker accommodation roof. So this all area, I will delete it. All area we will see it is in red color. So this required lightning protection system. In order to that, we have to know that where we have to place this air terminals. Okay, that will be determined by the formula D is equal to 2 under root 2 HR minus H square. So we will calculate now for our project. Okay, and as I told you, for our project, the earth rod, the air terminal rod is of 1.5 meter. Okay, as per our submittal, 1.5 meter. Now we have chosen class 2 protection. Okay, so the radius of the rolling spare is 30 meter. Height of our air terminal rod is 1.5 meter. Now we will place on this formula D is equal to 2 under root 2. 2 is constant, 30 is the rolling spare radius in meter, 1.5 is the height of the rod minus H square, that is the height of the rod square. It's a simple mathematics. When we will calculate it, we will come to know that the distance between the two air terminal to be 18.73 meter. Okay, so what we will do? We will place the air terminal over the roof at a distance of 18.73 meter. Here you see, this is the ready-made table provided by the IEC. So here, as our rod height is 1.5 meter and the class is lighting protection class is 2. So here you can see that the distance between the two lightning protection point, lightning air terminal point to be 18.7 meter, which is equal to our calculated value. So from this chart also we can select direct value by selecting our rod size, by selecting our LPS class, and we can go for the distance between the two air terminals. As I told you in beginning of this series that our project length is 73.60 meter and width is 13.6 meter. As we come to know that we need air terminals in the roof which should have a separation max to max of 18.73 meter. So what would be the number of rod along the length of the building? It is the length of the building divided by the separation between the two rod. So it came as approximate 4 rods we required along the length. And we know the width of the building is 13.6 meter. So number of rod along the width of the building is width of the building divided by the distance between the two air terminal rod. So it came as 0.73. So we can say approx 1 rod is required along the width of our project. So here is our project. Okay, this is the length of our project 73.6, and this is the width of our project, that is 13.6. As we came to know, along the length we need 4 air terminals. So here you see 1 air terminal, 2nd air terminal, 3rd air terminal, and 4 air terminal. In same way, other side 4 air terminal over the length, along the length of the project. Along the width of the project we need 1 air terminal as per our calculation here. So here you see there is 1 air rod along the width of the air terminal. Now for time being, ignore this mesh that I will discuss later when I will discuss the mesh method. As I told you in my beginning that for a particular project we can go for rolling sphere method as well as the mesh method as well as the protection angle method. But as of now, as per the rolling sphere method, we design our lightning protection system that all over the roof we need around 10 air terminals, 4 along the one side of the length, 4 along the another side of the length, and 2 along the width of the length. As we know, the length of the building is 73.6 meter and width of the building is 13.6 meter, and our calculated distance between the two air terminal is somewhat around 18.7 meter. Suppose the width of this building is not 13.6 meter but it is approximate of 40 meter. As the width of the building is 13 meter, so the air terminal distance is 13.6 meter along the width, and along the length is around 18 meter. Okay, as the width of the building increase from 13.6 to 40 meter, then if we will place one terminal here and one air terminal here, then the distance will reach 40 meter. But as we calculated the separation between the two air terminal to be 18.7 meter. In order to maintain this, we have to place 1 or 2 air terminal along the width of the project in order to have the separation between the two air terminals less than or equal to 18.7 meter. Hope you are very clear with this point. Now let us consider that there is one equipment in the roof floor. Okay, so as we seen that there is a imaginary rolling sphere, so there will be imaginary rolling sphere will rest on the lightning arrestor. I will make a cross section for this view. Okay, so let us consider this is that view. This is the two air terminal and the rolling sphere is touching this air terminal, and here is our equipment which is placed in the roof floor. As we have seen here that this is our air terminal height, but due to the curve nature of the rolling sphere method, it is coming inside our protection zone. This is called P, which is the penetration distance. Okay, so suppose if our equipment is that high that it will clash with this imaginary rolling sphere portion, it means this equipment is have a risk from the exposure of lightning strike. So we have to calculate this distance P, the penetration distance, in order to know that it is not clashing with our equipment which is placed in the top roof. Hope you are very clear with that. So in order to calculate this penetration distance, there is a formula given by IEC. P is equal to R minus root bracket R square minus D square divided by 4, where P is the penetration distance, R is the radius of rolling sphere, and the D is the distance between the two air terminal or two parallel air terminal, which is very important. Here I will come again to this picture. Here we have seen one air terminal. Here we have seen one air terminal. These two air terminal are not parallel to each other, but this two air terminal is parallel to each other, right? So we have to take always the distance between the two parallel air terminals as per the formula. Okay, two parallel air terminals. Now I will delete it for better understanding. I hope you very clear that we have placed the air terminals. Okay, but as the rolling sphere is in the curve nature, due to that it is penetrating inside the safer zone. Suppose if any equipment is placed in the roof and it is touching to this curve of the rolling sphere, it means this equipment is have a exposure risk to strike from the lightning. So we have to calculate this P in order to know that our equipment is in the safe zone or not. You will come to know, it will be more clear when we will do the numerical value. Okay. So as we know that our building width is 13.6 meter. Here you know that air terminal to air terminal distance is 18.6 meter as per our calculation. But we are checking this cross section, okay, this section. So the air terminal to air terminal distance is the width of the building, that is 13.6 meter. Hope you are very clear with this. So as per the formula, P is the penetration distance which we need to know. R is the rolling sphere method. We selected our building under class 2 LPS protection. So the rolling sphere radius will be 30 meter. And the D is the distance between the two air terminal, which is the equal to width of the building, that is 13.6. Hope you are very clear. Now we will place, in this photo it is very clear that we have equipment, okay, and this is our air terminal. This imaginary rolling sphere is penetrating under the safer zone. This is the height, okay, this is the rod, this is the height. So this distance is penetrating inside the safer zone. Suppose this equipment is bigger height and it is clashing to this penetrating zone, then it means this equipment is not safe from the lightning strike. Okay, so what we have to do, we have to calculate this distance and we have to analyze that our equipment are below this distance or not, in order to know that equipment which is placed over the roof is protected from the lightning strike. So what we will do, we have to calculate P. We know the radius of rolling sphere as per class 2 is 30 meter, and we know the distance between the two parallel air terminal, that is 13.6. We will substitute on this formula. P is equal to R minus under root R square minus D square by 4. When we will calculate it through simple mathematics, we will come to know that it is 0.78 meter. Now, this is the photo. So this penetration distance is how much? Here is 0.78 meter. Okay, suppose our equipment is 0.5 meter height. One example I am taking, 0.5 meter height. So P is equal to, penetration distance is equal to AB, point A to B, which I mention here, A to B, which is equal to 0.78. So I mention here it is 0.78. CD, the distance between this point to this point, CD is the equipment height, which is I consider 0.5 in my first example. So AD is equal to H is equal to 0.5. This is the A and this is the D. So A to D is the height of the air terminal, which is 1.5 as per our previous example. So we need to know BC. What is BC? So BC is equal to, what would be BC? BC is equal to AD, this is AD minus AB minus CD, right? We will subtract this height from, this height and this height from this height to know BC. So we have done same, we got to know its value is 0.22. So we came to know the value of BC is 0.22. It is in positive. It means there is a distance after the penetration which is 0.22. So our equipment is not touching this penetrating rolling sphere. Hope you are very clear. Now consider our equipment is not 0.5 height, but it is 1 meter height. Okay. Then we will, in same way, we will calculate here BC. So we will come to know our BC value is minus 0.28. Means our equipment is clashing with the penetrating distance. It means our equipment is exposed to the lightning arrestor. Hope you are very clear with this point. I have given you both the example. When the height of the equipment is just 0.5, then our equipment is not touching to the penetration of the rolling sphere. In that case, our equipment is safe. The another example I took, when I increase the height of the equipment from 0.5 to 1 meter. In that case, we find that our equipment is clashing with the imaginary rolling sphere. It means it is in the risk from the lightning strike. So in first case, we need not to change anything. Our equipment is safe from the lightning strike, so we need not to change anything. But in second example, when our equipment height is more and it is clashing with the penetration height, then what we have to do? We have to either change the air terminal height. Here our before case our air terminal height was 1.5 meter. We have to take it to 2 meter. In that case, we will have this BC value in positive, and again our equipment will be in safer zone. If we have cost limitation and we cannot change the height of the rod air terminal, then what we have to do? We have to place one concrete blocks or some supporting platform we have to make, and over it we have to place our lightning protection air terminal. If we will do so, the resultant height of the air terminal rod will increase. Though the actual height is 1.5 meter, but the resultant height will change from 1.5 to, let's say it is 0.5, so it will change to 2 meter. In that case also, the BC value will be in the positive, and we can say that our equipment is safe from the penetrating. Equipment is not clashing with the penetrating depth, and our equipment is safe. Hope you are very clear with this point. As we seen our calculation that when the distance between the two air terminal is 13.6 meter, then the penetration depth is 0.78. We calculated this one. This is the table given by IEC. So what is the distance between the two air terminal? In our case is 13.6, which is almost equal to 14 meter. Okay, and we have chosen class 2 protection. So as per this chart, it is given 0.83 the penetration distance. As our distance between the two air terminal is not 14 meter but 13.6 meter, so our penetration distance came 0.78 meter, which is almost nearby to 0.83 meter. So what is the conclusion? You can use this formula to calculate the accurate penetration depth, or you can use this table, ready-made table given by IEC, to know the penetration depth as per your class and the distance between the two air terminal. Hope you are very clear with this point. Here I want to highlight some important point mentioned in the IEC standard related to lightning protection system. Suppose our structure is less than 60 meter. The height of the structure is less than 60 meter. Then the side strike will be almost zero, and we have to give protection over the top only. As you see, it is mentioned in the red color. Okay, but suppose if our structure is greater than 60 meter and less than 120 meter, then the 20% of the side of the structure is unprotected and the top fully will be unprotected from the lightning strike. So we have to design the lightning system for the side strike up to 20% of the height of the building and all over the top. If our building is greater than 120 meter, then any portion which is greater than 120 meter need to have lightning protection design, including roof floor, as there is a chance of lightning strike through the sideway of the building. So what is the conclusion? If the building height is less than 60 meter, only at the top roof floor we need the protection. We need the lightning protection system. If the building height is between 60 meter to 120 meter, then 20% of the building height we need to consider as a unprotected zone for the lightning strike, and we have to design the lightning protection system for the roof as well as 20% of the height of the building. If the building is greater than 120 meter, then any height after 120 meter need to be considered as unprotected, and we have to provide protection against lightning strike to the building. Here I want to highlight one important point, which is a misconception between the designers. As per the rolling sphere method, we determine the position of the air terminal. Okay, and this air terminal must be looped with each other. So here you have seen we looped all air terminal with each other. This looping is not a mesh method. Here it is mentioned, mesh conductor used as a air terminal termination should not be confused with the mesh method. We are connecting the air terminals by using the copper tape in order to loop it, but this looping is not a mesh method. Okay, it is just a mesh conductor which is looping the air terminals. This is all about the rolling sphere method. In this video, we covered how to calculate the spacing between the two air terminals by using the rolling sphere method, as well as we calculated the penetration depth in order to know that any equipment placed in the roof is under the protected zone or not. In next video, I will cover about the protection angle method, and upcoming video I will discuss about the mesh method. And in any other upcoming video, I will do the comparison between the rolling sphere method and the protection angle method. I hope you find this video informative. If you really like this video, then please hit the thumbs up button, press the bell icon and subscribe to my channel. And don't forget to share this video with your electrical friends. We will meet in any other video. Till then, take care, keep learning, and bye-bye. Thank you so much.